Hello and welcome. This is the Synergetic Livestream. It is Synergetics Livestream 4.0. My name is Daniel Friedman, and today we are going to be talking about a couple of different topics in the realm of synergetics. Let's get started. Today in Synergetics Livestream 4.0, there's a couple spirits for the day, and then we'll talk about what we're going to go through for the rest of this livestream. The spirit for today is threefold. Let me just mute this. The spirit for the day is threefold: union, containment, and art. So by union, we think about integration and about how there's a unification of disparate elements. In containment, we see a nod towards the space filling concept and the idea of using volume as primary rather than points or edges or faces of shapes. And also the idea of in and out is going to come back soon. And the third term for today is art, because it's a short word, it's a powerful word, and it conveys a lot of the elegance that we want to bring to the thinking around synergetics. Today in 4.0, we're going to go through a couple of things. As usual, we're going to walk over the key memes and themes and the things to integrate, which are accreting from time to time. And then we're going to go into a couple readings of the text. First, we're going to read a non-synergetics section. We're going to read a little bit from an essay called Reading Synergetics by C.J. Fearnley. And then there will be two selections from Synergetics itself, section 310, Oddball, and 820, Tools of Geometry. Let's just rehash some of these key memes and themes, because no matter how many times one hears them, there just can't be too many times to come back to these great ideas. So what is synergetics? Synergetics is relational and multi-scale thinking. It is connected to our accessible experience as well as to abstract ideas that are also experiences we can have. In synergetics, there isn't an infinitesimal, and also there's a deprioritization of lines, points, and planes with an increased focus on volumes and space-filling things. Synergetics sees design as anticipatory, or in other words, cybernetic, and as a science. So it's something that we can carry out in the current moment in anticipation of the design need that we're going to need in the future. Just like a roof is designed in anticipation of the rainstorm, well, all of thought and design is in a way anticipating future events, stimuli, surprises. Tensegrity, which is related to the engineering of physical objects, is related to synergetics, kind of how engineering is related to physics. So physics and synergetics are more abstract. This is where we're dealing with things like topology, vectorial geometry, and so on, whereas tensegrity and engineering have more to do with structural stability and the sort of logistics of building these actual structures. A few things that we've pulled out from previous synergetic streams is that universe is the total scenario, and scenario just means setup. Universe, you don't need to add a qualifier, the, because there's only universe. There's no the universe. And any system within universe is a subsystem, and all systems have shape. These systems enclose space, and so they're space-filling systems, and that is why synergetics is the geometry of thinking, because we're going to be thinking about how to talk about these shapes and the relationships of these shapes to each other for all these kinds of different systems that we care about, including systems of thought, which are like metaphysical things, shapes. And this 4D thinking, 4D time lock, pervades through many different aspects of synergetics. Just to bring up a couple of ways that 4D plays out, there's a focus on tetrahedron, which is the shape where all four sides are equilateral triangles or other types of triangles, and a 60-degree focus rather than a focus on quadrilaterals with their rectilinear 90-degree angles. And there's other definitions of 4D, four-dimensional, as brought up by Kirby Erner down here on this slide. Down here on the things to integrate, I've added in a couple of great points and comments from Heather Strong, and I'm just starting to learn about some of these areas, but they'll play out hopefully in future streams. What was Bucky's intention in making synergetics, or what was his end game? What are our intentions in learning and working with synergetics? What are the connections between synergetics and symmetry, or the E8 groups, and all of these other algebras and group symmetry things that we're just all learning about? And as always, there's the links that we can take to computational approaches in Synergetics, and then there's a couple of sections that we're going to read when we get the chance. Let's go back to our cover slide and recall that we're going to look at C.J. Fearnley's essay, Reading Synergetics. Then we're going to look at a brief comment that was very insightful by Kelly Ritchie, and then we're going to be jumping into these two sections of the text, 310.10 and 820. So first, this is most of the essay. I like it when the essay can fit on one slide of C.J. Fearnley, and the URL is at the top of this slide. And in this essay, C.J. gives a very thoughtful helping hand to those who are reading Synergetics. And there's many helpful comments that are dispersed all across the internet throughout so many books, but this is just like a list of 9 things that we can look at, evaluate, and say, oh yeah, I could see how that would come into play when we're thinking about Synergetics. So starting with point 1, and I'd encourage people to read this essay in full if they're curious. Chapter 2 is like the claims section of a patent application. It is more of a summary than the introduction. Most of its contents are better explained later on. If you get stuck, you can skip it. And so we went through different sections of Chapter 2, not the whole thing, in Synergetic Stream 1 and 3. So I totally agree with CJ on this one, that Chapter 1 is almost like a knock at the door, but it's not quite an introduction, and Chapter 2 is really a nice summary. Point 2, start a Synergetics notebook. Mine is this slide presentation. Include questions and problems you have with the text and its content. Write an analysis of these difficulties, or do a live stream. Record your hypotheses about what Fuller is trying to say in each passage. That's what I am trying to do. Also include any reflections or ideas that the text may inspire, even if they seem far removed from the gist. The idea is this: the text interacts with itself synergetically. So it's important to have well-developed ideas about each section. Then you can build upon your dawning understanding as you read additional passages and try to integrate them. By degrees, comprehension will come. Really a nice point, and I agree. Number 3, from reading Synergetics. Build models to visualize and test concepts and assertions in the text. And sometimes the models can be really simple and silly. Other times you might go down the rabbit hole and want to build something quite sophisticated. 4. Remember, you are really only interested in the truth. Fuller challenges us to develop our own notions about reality. Fuller's writing seems to say, here is something that is very interesting. This is what I think about it. Look at the system he points at. Search for the significance, properties, and interrelationships of these systems. So elsewhere, I frame this as just Bucky being a prompt for our own thinking and our own thought process. And so that helps us approach the material with a beginner's mind and with an open mind. And also it's an approach that helps us develop in relationship to the text and in relationship to a community of learners and of practitioners. 5. Think of Synergetics as a guide to discovering universe. The particular ideas presented may be less important than the effect upon one's attitude, thinking processes, and way of looking at the world. So Synergetics is kind of a whole system for thought, if not, at the very least, just geometry. And just like most people don't walk around all day thinking, wow, I don't know the basics about geometry, it doesn't stop people in their regular life. Now, they might know that there's people who are doing advanced geometry research or be aware that there's unsolved questions in geometry, but that doesn't stop us in our day-to-day when we're walking around or riding on a bicycle. So similarly, the Synergetics journey is our guide to discovering universe. And so it's about the journey that we're on, and it's not about replacing some previous way of thinking with just pasting over it with a new way of thinking and waiting until we have that new way of thinking prepared before we act. Synergetics is a journey that we're all on. 6. Recognize any path-opening work will have some contradictions and scattered errors in it. Try to ferret them out and resolve them. 7. Synergetics is not a program which you plug into your head. It's not a super algorithm for understanding the universe. It is instead a worldview or approach one takes to look at the world. It is often more revealing than one's previous views. So like complexity science, it's an approach that we're taking, but it's not an answer, because feeling satisfied with a given answer, that's always in our head. That's psychological. And Synergetics is not something that we're just going to plug in and have it run on our hardware or wetware, and all of a sudden we're going to be doing different things in the world. It's actually an active and a curious approach that we take. 8. Synergetics is systemic. Often we try to get one frame view of the universe, but in Synergetics we have many interacting systems or many frames of reference. We must change our angular perspective to focus on the relationships we're interested in. Often in Synergetics, some interesting question will only be partially and tantalizingly explored by Fuller in the text. For example, he'll bring up some number, the golden ratio or something like that, and then instantly we'll just dismiss it and move on. So you begin to ask some of your own questions. Now is the time to begin an investigation, to try your hand at cosmic fishing. In order to answer your questions, you may have to repeatedly change tacks and reconsider the system anew until gradually the resolution of the problem becomes apparent. So there's this headwind because we're doing something that's challenging. We're working. So it's like we're sailing into the headwind. And so we have to do this zigzag and tack into the wind so that we can go upstream in our cosmic fishing journey. Because the further we can go and the faster we can go and the more agile our ship can be, the better fishing we're going to be reaching. And also, just one more thought on this partially revealed by Fuller in the text, Synergetics isn't the end point. In fact, it's barely even anything more than the tip of the iceberg. So it's more like a regular style of writing where, whether a scientific paper or a book, somebody makes a point or makes a conclusion or wants to highlight something, and then it's tell them what you're going to tell them what you told them, and tell them again, or something like that. It's about repeating what one has found. Now, Bucky does do that, but it turns out that what he seeks to emphasize and embed is his approach, which is Synergetics. Often there'll be an outcome or a conclusion or a lower level finding inside of Synergetics, and that will just be cast off because mentioning it once is enough. For example, once you mention one time that the ratio of two different shapes is the golden ratio, then it's good enough to know that anyone who is paying attention is going to be thinking about the golden ratio in relationship to these other shapes. So that single point doesn't have to be emphasized that much. So we see in Bucky sometimes things that seem critical and are only mentioned one time or maybe even never mentioned. And there's other things where they're not immediately apparent why they're so important, yet they're always going back to it again and again and again. And point 9, if you get a copy of Synergetics 2, and I have one right here. So Synergetics, the first one is a red one, and then Synergetics 2 is a white cover. And they are not like a prequel or a sequel. Rather, they're related through the same decimal numbering system. So they're kind of intercalated with each other. And CJ writes, if you get a copy of Synergetics 2, read the Demas model scenario, section 986. This is an excellent introduction to both volumes. I agree, and I added it to things to integrate later. We'll check out the Demas model scenario next time. So thanks, CJ, for all the great work and for this really excellent essay. Let's look at a couple of comments by Kelly Ritchie and think about what they might be speaking to, because it was very insightful. Kelly wrote, interested in, out, around? I'm not going to try to do a certain accent when there's capitals or not. I don't know what it means. It could mean something. Where is betweenness? As a tetrahedron model of four nesses, in, out, plus between, around, seems to be a sound working model combined with past, present, future me. I now have a working model relating me as a starting point for the conceptual model of single beingness. It then becomes the being or the one and only, a signal point broadcasting out to the edges of the universe. So I just drew out a few little aspects from what I kind of got at with Kelly's nice comment. So there are 4 vertex operations that are mentioned: in, out, around, and between. Now, in and out are in definition to something that's closed. Like if you have a paper bag, something can be in the paper bag or it can be out of the paper bag. Or if you have an interface like a Markov blanket, you can have something that's inbound or outbound. But it's always defined to a closed shape. And again, there isn't any open infinite plane in Synergetics. So we never talk about up or down. We don't say the plane is taking off or I'm going upstairs. You say I'm going outstairs because you're going out with relationship to the earth. You can also say I'm going out of the house, and that could be outside because that's in relationship to the house as the interface. So we have in and out, which are kind of like up and down. And then we have two more relational edges, which are between and around. So these are kind of relationships that things can have, either inside or outside of a space enclosure, or there can be a betweenness and an aroundness. And in the relationships of these four different things that constitute a tetrahedron, there is a unity of one. One what? One tetra. It's going to have a volume of one, and it's going to be consistent with that phrase that we've heard, which is that unity is plural and at minimum two. And it's almost like it's a reflexive design, because by defining these four operations in the points of the tetrahedra, we make a tetrahedra that has in, out, around, and between. And the between could be between us and the tetrahedra, or between 2 points. There's always multiple ways of thinking about it. Then we see this past, present, future me. So we can think of it as the past, present, and future, or the whole timeline, the whole developmental past, and the whole adjacent possible, and the deep, deep, deep time, service through deep time for this tetrahedra, for that unity, for that narrative, that story. Now, a signal point broadcasting out to the edge of universe. This is kind of like the omnisymmetric radiation of energy. And we've talked about the lightning strike example, about how when there's a lightning strike, the light moves faster than the sound. And so it's kind of like these two spheres, and one moves faster than another. And the light one is allegedly bounded by the maximum speed limit in the universe, the speed of light, at least according to our observation. And then the sound one moves significantly slower than that. And as Bucky pointed out, I think last time, it was the recognition that light was not instantaneous that led to the necessity of thinking about this omnisymmetrical sphere exploding world. And so here, a signal point broadcasting out to the edges of universe. Well, it's a bidirectional relationship. If there was some star and the light hadn't reached Earth, then we wouldn't be able to perceive it. It would be outside of our Umwelt. It wouldn't be part of our observations, so it wouldn't be able to update our generative model of the world. We might have known about it from another source, but at least as far as the direct observations go, we wouldn't be able to be in contact with it. And so the happening, the energy event, the point, but it's not a mathematical point like a dimensionless thing. It's just a tiny, tiny kernel, like a crystal, a small tetrahedron. It both receives from all of the universe that's in contact with it over the time scale of the analysis, and it broadcasts out. So you get four relational things, and somehow four relational things become one and only being, unity. And that unity is a signal. It's a point, again, not in the mathematical sense that most people would understand it in, but it's a point like a speck, like something that's finite and discrete and bounded, not dimensionless and massless. And then it broadcasts out to the edge of the universe. So you don't even need to speculate. Electromagnetism absolutely broadcasts out to the edge of the universe. So this was a really nice comment by Kelly, and I always appreciate Kelly's comments and any other comments people have. If they just put it in a YouTube comment, I'll try to address them. But I just thought this was great because we saw some sort of meta, self-reflexive tetrahedron action in the past, present, and future. We got the time crystal tetrahedron. It's just great times. All right. It's been almost 20 minutes. Let's go to the two sections of text that we're going to look at today. Slide 199 has Synergetics section 310.10 oddball. We're going to read the section of oddball and go through it with our usual approach, which is to read straight through, then reread, then give example, then question. So we're going to go through our usual ordering, and then we're going to jump back to the beginning and then go to our final sections of text. But this will just be a one-page selection. We will not go into the next section. 310.11. In Synergetics, we find the difference of exactly one whole integer frequently manifest in our geometrical interrelationship explorations. Beyond the one additional proton and one additional electron that progressively characterize the hierarchy of the already discovered family of 92 regenerative chemical elements and their short-lived transuranium manifestability by high-energy physics experiments, we find time and time again a single integer to be associated with a positive, negative, energetic pulsation in universe. Because the energetic synergetic relationships are usually generalized relationships independent of size, these single rational integer differentials are frequently found to characterize the limit magnitudes of asymmetric deviation from the zero-phase vector equilibrium. Pretty interesting, and some things we've all heard of, like elements in the periodic table, and other things that are just like, wait, what was a zero-phase vector? So, in synergetics, there is often a difference of exactly one whole integer. Well, that's not too surprising because we're dealing with basically integer math. So there might be some integers that pop out and they're kind of already rabbits been placed in the hat, and there might be other integers that pop out and it's genuinely surprising. It turns out that these integer relationships, like 1, 2, 3, 4, 5, frequently manifest in the geometrical relationships that we're exploring, which is to say, everything we're doing here. One example of these whole integers and how you have a series of things that are geometrically and numerologically linked through integer intervals, integer, interval, similar words. An example of that is the periodic table, where as you increase up the periodic table, or as you increase through the simplest atomic element, hydrogen, which is just a proton and an electron, all the way up to the 92nd, which is uranium, you add a proton and an electron. And so a conventional understanding, or the one that you might get in chemistry class, would be, well, adding a proton is what defines it as a different element. That's Z. That's the actual nuclear number. And then you have to add an electron to keep the charge balanced. And then once you have the charge balanced, depending on the valence and the orbitals and all this other stuff, sometimes you gain or lose a couple of electrons to get into a more stable energetic state. So sodium loses an extra electron from its valence, and that's why sodium exists as Na+, for example. Bucky's going to give a different explanation. He's suggesting that actually adding the proton is something that's geometric and happening in the nucleus, and then adding the electron is also something that's geometric. So not just based upon charge balance, but actually upon the geometry of how things are related. Bucky says that a single integer is often associated with this positive-negative energetic pulsation. We find time and again a single integer. I'm not sure if a single integer means 1 or if that means 2. Because these energetic relationships are usually generalized relationships independent of size, so that's making us remember the whole distinction from a few times ago with things that have shape are everything, physical or metaphysical. Now, physical things have shape, they have size, they're dependent on their actual manifestation. Metaphysical, like the idea, is not dependent on shape, like triangle is it's size independent. These metaphysical relationships that are independent of size are frequently found to characterize the limit magnitudes of asymmetric deviations from the zero-phase vector equilibrium. So this one, I'm not exactly sure what is meant by the zero-phase vector equilibrium, but this is like the neutral point. And so it's almost like there's this increment. We're going to be adding one, adding one, adding one. And then it's like we're going uphill, and then we like reset and we go up another octave. So it's kind of like incrementing and going through musical scales. And also this has to do with the wave and the number line that we looked at in numerology in the 1200. And there's a few other places that we could talk about, but we're not going to go into that 1043 today. This is just to say that sometimes by incrementing 1, 1, 1, 1, 1 or 2, 2, 2, 2, 2, sometimes you get this oscillatory, fluctuating positive, negative behavior. So for example, if you have 1, 2, 3, 4, 5, and then all of a sudden you start taking them down, and then you add them back up, and then you start taking them back down. So that's like this positive, negative, fluctuating behavior that's built upon adding increments of integers. So it's not built upon multiplying or subtraction, and it's not built upon non-integers. 12. The minor aberrations of otherwise, so a question I would have is what is the asymmetric deviation from the zero-phase vector? And an example would be the geometry of the elements in the periodic table. 12. The minor aberrations of otherwise elegantly matching phenomena of nature, such as the microweight aberrations of the 92 regenerative chemical elements in respect to their atomic numbers, were not explained until isotopes and their neutrons were discovered a few decades ago. Such discoveries numerically elucidate the whole integer rationalization of the unique isotopal system's structural proclivity agglomeratings. What kind of ratings? Agglomeratings. So aberration has a negative connotation, but in this context, it could be replaced with residual or differential. So the small differentials of the otherwise matching phenomena were not explained. Well, what was this microweight aberration? Well, people understood that adding a single proton was what was differentiating elements from one another. However, the weights were not just changing, their atomic masses were not just changing by one. So it wasn't just going 1, 2, 3, 4, 5 as the atomic number went from 1, 2, 3, 4, 5. The masses were changing, first off, in ways that were discretely different. It turns out that was related to neutrons, which have the same, or they have a very similar mass to a proton within 1/1837th, if you know what I mean. They have a very similar mass to a proton. However, they carry no charge. And then isotopes are versions of the same element that have different mass because they have the same number of protons in their nucleus, but they have a different number of neutrons. And that means that the geometry of the close-packed nucleus is different. Why is the nucleus close-packed? Because it's events, happenings, energy at spatial and temporal scales that favors the aggregation or the structural proclivity agglomeratings. So that's why we're always talking about the close packing of the spheres, because we could think about just physically packing things together. Again, shape has a space has a shape. You can't pack those oranges in any way. The lowest energy packing is going to be a couple of different close packings. And so this is just an example of where synergetics meets nuclear physics, because we're thinking about the nucleus as a close packed thing, where the strong forces and the nuclear forces, all these interacting forces, are leading to this tightly energetically bundled nucleus with, yes, electrons that are also charge balancing, but we can think about the nucleus and really the whole atom as this geometrical event. And Bucky is saying that we can make sense of the macro and the micro fluctuations in the weights when we think about structure, but not if we think about just how many points are being racked up in the imaginary chemical Olympics. That's like going down a fantasy road. We're going to go down a realist road, but an instrumentalist one. We're going to be thinking realistically, pragmatically about how we're going to study nuclei. And we're going to do that with close packing and energy. One question I would have would be, what did Bucky know about regular chemistry, or what was known about chemistry, and what kinds of things are we learning in the last couple of years that might be changing our understanding of chemistry? And then one example might be the different isotopes of uranium. So with 92 protons, depending on how many isotopes, depending on which isotope there is, there's a different amount of reactivity potential. And that's not chemical, that's nuclear reactivity potential. So 13. This is where the oddball comes into play. There is a phenomenon that we might describe as the eternal disquietude of the oddball, promulgating eternal reorderings, realignment, and inexorable transformings to accommodate the eternal regeneration integrity of intellectually differentiable universe. This suggests philosophically that the individual metaphysical human viewpoint, the individual ego of the human, is indeed an essential function of the eternally regenerative integrity of the complex, law-governed universe. It's two sentences, but it's very powerful. Let's look at this first sentence. There's a phenomena that we're going to refer as the oddball. So it's kind of like we have the perfect packing of all of the spheres. And then we add one more on top. So we have all the protons and neutrons, and it's in a nice shell, and then we add the oddball on top. Yes, there's the electron with a charge balancing as well out in the orbitals, but the oddball is like this capstone on top of the otherwise ordered and static and symmetrical shell. That's what makes it the oddball, and that is this difference of exactly one whole integer. That's the oddball. What does the oddball do? Well, the oddball promulgates kind of like entropy or anxiety or free energy, maybe. It promulgates or it puts forward or it catalyzes eternal reorderings, realignments, and transformations. And why are those transformations happening? It's not just meaningless machinations for Bucky. It's in order to accommodate the eternal regeneration of integrity of universe. So oddball is this phenomena that Bucky's saying is kind of generalizable, which is this motivating sort of thorn in one side of a system that leads it to be eternally reordering, and not just in a way that's breaking down or dissolving order, but it's actually regenerating order. What does that suggest? Well, it suggests, second sentence, that our human viewpoints, each one of our perspectives, the individual ego of the human, is an essential function of the law-governed universe. So that's really cool, because there's a claim about this generalizable phenomena, and then there's a connection between the oddball and how that's this asymmetrical deviation from the zero-phase vector equilibrium. And that's us. The human is this local sense maker that is the asymmetric deviation from the zero-phase vector equilibrium. There could just be a desert with no people in it, but it's not that way. There are people, and they are doing sense-making. An example of this, one example was the physical sphere packing with a ball being put on top. Another one might be a new idea. So you have an ecosystem of ideas, and then there's a person or an idea that comes onto the scene, and it's an oddball. And so how does the system react or reorganize around that new fulcrum or stimuli? So my question would be, how do we recognize the oddballs and use oddballs' abilities to make systems that work better for everyone? 14. Possibly, this mathematical oddball oneness inherently regenerates the ever reborn ego. Just when you think you are negative, you find you are positively so. This is the eternal wellspring of positive-negative regeneration, of acceleratingly heating entropy and cooling off syntropy, which is synergetically interoperative between the inherently terminal physical differentiating and the inherently eternal metaphysical integration. Just a couple of sentences, two short ones and one long one, but what an amazing section. So, this is a speculation in the first sentence. Possibly, this oddball phenomena is what is regenerating our identity. So, Bucky's going from first the observation that there's this oddball trend where you have the discrete addition of integers, and that causes systemic rearrangements like nuclear reactions. And then as an example of that, with more of a psychological twist about, again, how adding the increments can lead to these oscillatory changes or emergence. More is different. That's what we say in complexity. He says, just when you think you are negative, you find you are positively so. So it's a pun. There's at least two interpretations here. One is like, just when you think your rate of change is negative, you find that you're going to be now turning into the next phase of the turn, the next turning. So just when you think you're negative, by the time you've caught on to how things are, you're already moving in the next direction. And then there's a second pun joke, which is just when you think you're negative, you find you are positively so. So here, like, I'm positive, I'm definite. So it's saying, whether you think you can or not, you're right. So this is like, when you think that you're negative, you are. So it's kind of a funny pun by Bucky. This is the eternal wellspring. So we move from speculation to claims, but why not? This is the eternal wellspring of the positive-negative regeneration. So let's pause there. We're taking this interesting trend, which is that we increment 1, 1, 1, 1, 1, 1, 1. We're adding protons and electrons into the atom, and we're getting these shells that are organizing. So we get these categorical, discrete, and phase transitions, all kinds of interesting behavior from adding 1, 1, 1, 1, 1. And we also, importantly, by adding finiteness, we also get this oscillation with a positive and negative. Because there's no negative numbers in synergetics. There is 5, and then you take away 3, and now you have 2. We're not going to contend that, but there isn't -2, because -2 what? It's like having -2 as a speed. Can't have it. So this phenomena of the oddball and the way it plays out across all these cool systems is going to be tied to positive and negative fluctuations of what? Accelerating, heating, entropy, and cooling off syntropy. So heating and entropy are tied up because it's like saying when disorder is happening, when the energy is going towards the heat side, it's like entropy. So the potential is being released as heat. That's entropy in Bucky's framing. And cooling off is syntropy, which means that the temperature is going down, but the order is going up. So it's kind of like how the change in free energy in chemistry, not even in active inference or the Carl Friston territory, but it's like the entropy and the enthalpy terms. So the order and then how exothermic the reaction is. So reactions that are exothermic sometimes can organize a little bit because they release a ton of heat. And so that's what makes the reaction go down the road. So Bucky's saying you have this positive negative via accumulation of integers that's giving us both the entropy and syntropy, or negentropy, as Schrodinger might have called it, both phases, just like rise and fall are part of the clock cycle or part of your lungs. Entropy and syntropy are part of this broader oddball paradigm. They're in fact synergetically interoperative between these two different things. What are the two different things? Physical differentiating, which is terminal, and then metaphysical integration, which is eternal. So just as with many other binaries, we're going to like line up everything on one side of the binary or the other. So here we have the terminal physical differentiating, acceleratingly heating entropy, and the cooling off of syntropy, which is the eternal metaphysical integration, because it's more orderly. That's why they say someone's a cool guy. It means that there's a lot of syntropy happening in their mind. So what a fun section with Oddball. This is something I hadn't looked at in a long time, so it's good to check it out. And one question I would have would just be, how have people applied the Oddball paradigm? How have people modeled it? What kind of models exist for this, whether physical or computational or anything else? That concludes 310.10. We jump back to slide 2, and now we're going to go into the 2 slides related to 820.00 tools of geometry. So this one's pretty fun. We're going to go through this slide and the next slide. 1. So this section is going to be about the history of geometry, and it's going to be about the media and the message. It's going to be about the ways that we think about things and the reification of metaphors, and about what is a map and what's the territory, and what is an angle and what is a line. It's going to be a great journey. 1. The early Greek geometers and their Egyptian and Babylonian predecessors pursued the science of geometry with 3 basic tools: dividers, the straight edge, and the scriber. They established the first rule of the game of geometry, that they could not introduce information into their exploration unless it was acquired empirically as constructed by the use of these tools. With the progressive interactive use of these 3 tools, they produced modular areas, angles, and linear spaces. Okay, so here's who was doing it. Early Greek, Egyptians, and Babylonians, but Bucky's just using that to mean the past, the ancients, antiquity. And there was 3 tools that were utilized in geometry: the divider, the edge, and the scriber. And so that's kind of like saying straight edge and pen. We'll get to the divider soon. And this idea of describing geometry as a game, like an infinite game or the glass bead game, is fun. And the game has a rule, which is that you have to use the tools of geometry to construct in that proof what you want to show. So if we had included a coin flip in the laws of geometry, then it'd be a different system. So there's many geometries, and in fact, there's geometries that we don't even know about. But for the geometry as we're playing it in this game, if somebody wants to play baseball and you have a different way of playing, or somebody wants to play chess and you set it up a different way, it doesn't make it better or worse. It's just a different game. It might be a more useful game or a more fun game or a game, whatever. But we're talking about different games. And so it's sidestepping a lot of debates that hold up non-synergetic areas just by saying, yep, it's a game and we're defining it this way. How is it defined? By these specific people, by the use of these 3 tools. And they have to play this little game where they can construct things, but you can't bring any side information in. The only thing you can put on the table is the tools. And that's really important. Tools first. It turns out that by using these three tools interactively, they could get modular areas. So again, like the integer areas, like a square with 1 by 1 equals 1 area. They can make angles and also linear spaces. So spaces on the page. The question I'd have is, what other world knowledge traditions of geometry are there? And what do we know about them, or what do we not know about them? And an example of ancient geometry could be Euclid. And in Plutarch's Lives, there's some amazing work on, of course, history, but there's the way that geometers and geometry are described in Plutarch's Lives is really quite interesting for those who want to know about that part of history. 2, the basic flaw in their game was that they failed to identify and define as a tool the surface on which they inscribed. In absolute reality, the surface constituted a fourth tool absolutely essential to their demonstration. The absolute error of this oversight was missed at the time due to the minuscule size of a man in relationship to his planet Earth. While there were a few who conceived of the Earth as a sphere, they assumed that a local planar condition existed, which the vast majority of humans assumed to be extended to infinity, with a four-cornered Earth plane surrounded by the plane of water that went to infinity. This is, again, very subtle and powerful. So there's a flaw in the way that these three tools and implicitly the piece of paper were using geometry. So you didn't like geometry in school? Then Bucky's about to tell you what was wrong with it. So now when you have that lucid dream and you're back there with your geometry teacher, you'll know what to say. The basic flaw was they failed to identify as a tool the surface on which they were inscribing. So it's so interesting. They had three tools, but guess what? They had four tools. They had a tetrahedron of tools. They needed the piece of paper too. Or another way of saying that is there was the tools and then there was the perspective. And so they didn't understand that by looking at their perspective and their tooling as implicit, it was actually an incorrect generalization. Okay, how is it an incorrect generalization? Why does it matter that the surface is a fourth tool? Well, this is going to be very interesting for some who may or may not have heard of it before. Why is it so important that the flat piece of paper, the infinite plane, why is it so important that that is a tool, and how does the infinite plane invalidate that kind of an ancient geometry? Bucky says, the absolute error of this oversight, so this means total error and also quantifiable error, was missed at the time due to the minuscule size of man in relationship to his planet Earth. So locally, it seems pretty flat. Like, you know, you have a cup of water, it seems to be like pretty flat. Look across a short lake and it looks to be pretty flat. And there's other YouTube videos you could look at if you want to learn more about that. But suffice to say that when we think about the Earth with a roughly spherical shape, we still have a little cognitive dissonance. Even people who truly do believe and think that they have a justified belief that the Earth is roughly spherical, they still understand that locally it's defined by a sort of almost planar field. We even call it, you know, fields of grain, just like a field in space. Now, it really matters whether you're doing geometry on a flat infinite plane or on a curving plane. So imagine if you have a ball that's relatively small, like a grapefruit. If you draw a triangle on it, you'll find that the angles don't add up to 180. So when you make a triangle on a sphere, the angles don't add up to 180. In fact, the angles of a triangle, internal angles of a triangle, only add up to 180 on the infinite plane. Okay? So if you're dealing with any kind of sphere, especially a little one relative to the triangle, then it becomes ridiculous. So just think about a grapefruit and draw a big triangle over it, and you'll see that as the triangle gets bigger and bigger, the triangle becomes more and more far away from an internal angles summing to 180. So, Bucky says, there were people who understood that the Earth was a sphere, or they believed it to be that way, and then they thought, well, but sure, but we can still do the piece of paper. We should still be able to do geometry on this. We should still be able to use our straight edge and our scribe and our divider on this local plane. But it turns out that's fallacious. And the reason why it was missed is that humans are small relative to the size of Earth. And so it's kind of like you're on a plane, but, the Great Plains, for example, different spelling. But there is a slight curvature. And so if you take a triangle and you lay it on the ground, it will be almost flush with the ground. So you'll almost think that you're in this infinite plane where the angles sum to 180. But actually, any triangle on the Earth is not going to be 180. It's definitely not 180. It might be just so fractionally close that you can't even measure the difference. And there's areas of the Earth where it looks pretty flat for a pretty long period of time, but it doesn't go that way forever. And so this is just such an interesting approach that Bucky's saying is the belief that humans had that the four-cornered Earth with a plane of water surrounding it that went to infinity. So it's kind of like the four corners of this piece of paper and then off to infinity. And so on the piece of paper, the angles of the triangle internally sum to 180. But as soon as you're dealing with curved paper, all of a sudden the angles don't sum to 180. And so it's a fallacy to assume that just drawing on a piece of paper describes the shape of our space, because it doesn't. That's what's going to be so interesting to follow up on. And it is a significant error that when you're dealing with tiny triangles on the big Earth, it's not that big of a deal. That you can probably have a tolerance for a small error. But if you want to be absolutely correct, and if you want to be doing big things like big triangles on small circles, small spheres, you need to understand that the geometry isn't the way that it was laid out by these early geometers. So we're talking about the history of thought in geometry. 3. They assumed the complementary tool to be a plane, piece of paper. Because the plane went to infinity in all planar directions, it could not be defined and therefore was spontaneously overlooked as a tool essential to their empirical demonstrating. What they could not define, yet obviously needed, they identified by the ineffable title axiomatic, meaning everyone knows that. Had they recognized the essentiality of defining the fourth tool upon which they inscribed, and had they recognized that our Earth was spherical, ergo finite, ergo definite, they could have, and probably would have, employed strategies completely different from that of their initiation of geometry with the exclusive use of the plane. But to the eastern Mediterranean world, there lay the flat, infinite plane of the Earth at their feet upon which to scratch with the scriber. So that's related to what we've been just mentioning. It's assuming that because the plane went to infinity in all directions, it's like it's the canvas, it's the backdrop, it's our implicit biases, it's our implicit nature of cognition, it's the water that we swim in, it's the air that we breathe. These are our axioms. Now, Bucky calls axioms a little bit jokingly as things that everyone knows that. It's not necessarily that axiomatic means everybody knows that. Axiomatic means, according to a more formal logical perspective, there are claims that are not validated by empirical data, and they cannot necessarily be falsified by empirical data. So whether you think of them as assumptions or as starting points or as claims that are outside of falsificationism, that's what axiomatic means. But it's a really great point, and it reminds us of so many other things, like the Cartesian coordinate system. So that's taken as an assumption that that's the right coordinate system to use, rather than, for example, polar coordinates or some other type of more synergetics-friendly way of thinking about it. And then Bucky speculates that had they understood that their fourth tool was actually this limit case of the paper, which is very different from the Earth because the paper is a flat plane and the Earth isn't. Had they realized that, he's saying that they probably would have come up with different geometries, but they didn't. 10. Dividers. The ends of two sticks can be bound together to serve as dividers. A straight edge stick could be whittled by a knife and sighted for straightness and improved by more whittling. The opening of the dividers could be fixed by binding on a third stick between the other two ends, thus rigidifying by triangulation. Almost anyone at sea or in the desert could start playing this game. So the divider is kind of like an angle. Let's kind of walk through what he's saying with the ends of the two sticks. So we're going to take the ends of two sticks and we're going to bind them together. So it's kind of like we're binding together the ends of these two pens. And then you can make a straight edge stick by whittling down. So you're going to whittle this so that these two sticks are very straight with each other. The opening of the dividers could be fixed by binding on a third stick between the other two ends, thus rigidifying by triangulation, like this. Almost anyone at sea or in the desert could start playing this game. So, seems kind of interesting and curious, and one question I would have would be, where's Bucky going with this? And why do we talk about the compass and the straight edge today in geometry, but we don't talk as much about the divider? And it just, in general, is pretty interesting that we hear, again, more about compasses and straight edge, but the divider could play out as a compass. So maybe we're just at the level above compass. We're thinking about something beyond that. But it's just interesting about how, again, people usually think about the pen as the tool, but they don't think about paper as a tool. And it's just a great general point that sometimes it's the things that we don't recognize that are the assumptions that bear most heavily on the outcomes that we care about. So let's think about this. We'll go through this last slide, and that will be it for today for how these dividers came into play, and then we'll go through a little bit of classical geometry. It was easy for the Greeks. This is Greek scribing of right angle modularity in a plane. It was easy for the Greeks to use their fixed dividers to identify 2 points on the plane marked by the divider's two ends, A and B respectively. Employing their straight edge, they could inscribe the line between these 2 points, the line AB. Using one end of the dividers as the pivot point at one end of the line A, a circle can be described around which the original line terminal, circle A. Using point B as a center, a circle can be described around it, which we will call circle B. These two circles intersect one another at 2 points on either side of the line AB. We call that intersection points C and C prime. I'm going to read 3 and then we'll go through the diagram. By construction, they demonstrated that points C and C prime were both equidistant from point A and B. In this process, they have defined 2 equilateral triangles, ABC and ABC prime, with a congruent edge along the line AB and with the points C and C prime equidistant on either side from points A and B, respectively. So this does actually turn out to bear upon a compass. So people will think more today about a compass as an angle, a specifier, but the divider is kind of like a generalization or a precursor of a compass. So what happened and how did we get this diagram and what are we finding out? So we're going to get a fixed divider and then we're going to mark A and B. So whether we're going to take just the first compass, I'm just going to call it a compass instead of a divider, and the distance of our compass is going to be just A to B. So that's going to be just, it doesn't matter whether it's wide or narrow or whatever material it is because it's an idea. And then we're going to use our straight edge to connect A and B because 2 points make a line. So that's how we get A and the line AB and B. Then you're going to keep your divider at the same exact value. So with the same triangulation, same stick fixing it to the same opening. And then you're going to trace out a circle around A and trace out a circle around B. And because A and B, it's kind of like you could rotate the paper, there's a symmetry. It turns out that these 2 circles intersect and the line that's drawn between C and C prime, the 2 points of intersection, that line not just bisects AB, but also it creates equilateral triangles ABC and then ABC prime. And at point D, the center of the cross, those are orthogonal lines. And so the right angles are guaranteed, again, by symmetry. That's described here. They then used a straight edge to connect the points C and C prime with a line that they said bisected line AB perpendicularly, being generated by being equidistant from either point on either side. Thus, the Greeks arrived at their right triangle. In fact, there are 4 right triangles. So that's ADC, CDB, BDC prime, and ADC prime. We designate at point D the intersection of these lines CC prime and AB. This gave the Greeks 4 angles around a common point. The 4 angles that I just mentioned have hypotenuses and legs that are, as is apparent from even the most casual inspection, of 3 different lengths. So BD is a different length than DC, so it just looks like a different length. And then the hypotenuse also looks like a different length. The leg DB, for instance, is by equidistance construction exactly 1/2 of AB. So DB is 1/2 AB, we know that, since AB was the radius of the two original circles whose circumference ran through each other's centers. By divider inspection, so this is just not quantitative, just asking, okay, given the compass, is it more or less? DB is less than CD, so DB is less than CD, seems fair, and CD is less than CB, because we know later that the hypotenuse is longer than one of the sides. The length of the line CD is unknown in respect to the original lines AB, BD, or AC, the lines that represented the original openings of the dividers. So let's just say that we got the dividers handed to us we knew that that was X. So now we know that AD is 1/2 X, but we don't know what these other ones are. They have established, however, with satisfaction of the rules of their game, that 360 degrees of circularity unity at D could be divided into 4 equal 90-degree angles entirely and evenly surrounding point D. So this was the big point of construction. And just remember, this is shapes on a plane, not space shapes. So these are shapes on the tool of the flat piece of paper, which isn't like the omnisymmetrical and sort of spherical or geodesic geometries that actually define real systems in the actual world and in thought. This is an idealization. These are not space shapes. They're not actual space-filling shapes. And then Bucky continues by talking about how you can go into hexagonal construction, but then he notes, and just to briefly go through this, that these lines could go out into infinity. And so the hexagon is really where we start seeing a lot of these close packing ideas come into play, and a lot more. So that's all I wanted to go through today, was just get to synergetic presentation of some basic ancient geometry, and then think about that as a jumping off point for maybe later when we want to be talking more about esoteric elements of geometry, or about non-Euclidean geometries, or the kinds of geometries that they don't teach in school yet. So that is actually it for today. I'm going to jump back to the start page, and let's just recap our spirit and then think about what we want to do going forward. So today we thought about union and about integrity and about holism. We thought about containment, about how can we channel, how do we define in and out, and about art and beauty and the good, the true, and the beautiful. And in 4.0, the tetrahedral episode, we did 4 things. There was the key memes and themes and the things to integrate. Those were sort of the backgrounds that we talked about. That doesn't count in this tetrahedron, I guess. And then we read through the essay Reading Synergetics by C.J. Fearnley. And we also went through Kelly Ritchie's comment about insideness and outsideness and between around. And then we walked through the oddball, which is sort of this idea that as you increment 1, 1, 1, 1, 1, or 2, 2, 2, 2, 2, as you increment, you get not just emergent behavior, more is different, but you actually get oscillatory or fluctuating behavior, and that can be seen on the periodic table as well as in other systems, potentially systems of thought or social systems. And then in 8.20, we just started briefly recapping where Bucky is situating the geometrical dynamics or the geometrical aspects of synergetics in relationship to the history of geometry. And it turns out that he's taking a historical, tool-centric approach in understanding how the psychology and the understandings of people and the tools that they had access to at different times, whether they didn't or didn't have an airplane or a spaceship or all this other kind of stuff, compass for that matter, how did the tools that people did or didn't have in feedback with thoughts that they did or didn't have result in the world that we do or don't have today? So it's been a pretty cool discussion. I'm looking forward to perhaps going into section 986 next time, as suggested by CJ in his essay, learning about a little bit more history, because there's actually a few deep dives into history and synergetics, in thinking about numerology as well as in geometry. And of course, there's other books that Bucky wrote that have a ton more history. So Synergetics is really just the bare minimums about how much history you need to know in order to be caught up on Synergetics. Well, that is it for Synergetic Stream 4.0. Thanks everybody for watching live or in replay. Hope that it was fun. And yeah, just leave a comment and I hope to have a conversation with you or hear a presentation from you, hear your questions or perspectives on a future Synergetic live stream, because that would be awesome. So thanks again and talk to you later.